Here we will look at volume of a frustum of a cone. So by frustum, we are looking at shapes like this. It is something like that. So as we can see, it is part of a cone from which the tip has been chopped off. So we can use this formula for the volume of the frustum, where R is the radius of the bigger circle at the base, and big R that is the small r, which is the radius of the smaller circle, and the height is the perpendicular distance between this r and that r. So for our example here, if R is 3.75 and small r is 3.75 centimeters and small r is 2.25 centimeters and h is maybe 8 centimeters. So we can find out V by putting the values in the formula. So that's 1/3 pi 3.75 square plus 3.75 times 2.25 plus 2.25 square times 8. So that should give us 230.91 centimeter cube. So that's the volume of this frustum. So there is another way of doing this without using the volume formula. So for example, maybe you forgot the formula in the examination hall. In that case, what you can do is you can deduce another way. You can deduce the formula using another strategy here. So suppose this one, so let's mark this as 2.25 and that one as 3.75 there, centimeters, and the height is 8 centimeters there. Now we will do some construction here, which is we'll complete the cone. So that's how we complete the cone there, and we draw the height there. So now we have two cones, one at the top, which is the smaller cone there. So that's the smaller cone at the top. Let's assume its height as L1. So suppose this height there, so let's suppose this height is L1. So that's L1. And now let's draw the bigger cone. So this is the bigger cone. And that's the height of the bigger cone. Let's assume that is L2. So here the difference between L2 and L1 is an 8. So we can write, what we can write is L2 equals L1 plus 8 centimeters. Now, because these two are overlapping, like this is a part of it, the smaller cone is a part of the bigger cone, so the ratio of the two radii is equal to, so the ratio of the small r and the big R should be equal to the ratio of the smaller height and the bigger height. So now if we substitute the values in this formula, we will get 2.25 over 3.75 equals L1 divided by L1 plus 8. So we are substituting the value of L2 as L1 plus 8 using this one there. So now if we simplify this equation, we will have 2.25 L1 plus 8 times 2.25 equals 3.75 L1. So bringing this 2.25 to the other side, we'll have 3.75 L1 minus 2.25 L1 equal to 8 times 2.25. So now, simplifying this, we will get 1.5 L1 equal to 18. This times that is 18. So L1 should be 18 divided by 1.5, which is 12. So we got this L1 as 12 centimeters. So this L2 should be 12 plus 8, which is 20 centimeters. Now the volume of this frustum, there, should be the volume of the bigger cone take away the volume of the smaller cone at the top. So we'll write the volume of the frustum should be equal to volume of big cone take away volume of small cone. So that is 1/3 pi 3.75 square 20 minus 1/3 pi 2.25 square times 12, because we are using the volume formula for a cone. That's 1/3 pi r square h. So if we simplify this, if we calculate this, we will get 230.91 approximately centimeter cubed. So that's another way of finding out the volume of a frustum without using the formula there.